Okay, so 28 we can't do because that's differentiation. We'll do 12 and 15. Let me open the worksheet again. Let's look at these questions then. Okay, 15 seems to be shorter. Let's start with this. Question number 15. All right, so it says find the term independent of x in the expansion of this thing. The term independent of x. Let me copy the formula here as well, so we have that in front. This is the formula. Okay, so it says find the term independent of x. What does that mean, independent of x? It means the constant term, the term that does not have an x in it. We can say x raised to a power 0. That's the term that we're looking for. So how did we use to approach such problems? We would say, let's just expand it using the formula like we usually do. X minus 1 over x squared whole raised to a power 9. Let's expand the first two terms because that is going to give us the pattern that we need, right? So that's what we do. Let's find the pattern. First term is a. So in place of a, we've got x. In place of b, we have minus 1 over x squared. And in place of n, we have 9. All right. Now we can just input values. What's a? A is x raised to a power n. So that means x raised to a power 9 plus nc1, that's 9c1 into a raised to power n minus 1, that's x raised to power 9 minus 1, which is 8, into minus 1 over x squared. Now, once you've done the expansion of the first two terms, what you can do is you can look at the pattern. What's the first power? The first power that we have here is x raised to a power 9. All right, that's the first power. What about the second power? We've got x raised to a power 8 in the numerator. We have x squared in the denominator. X raised to power 8 minus 2, that's x raised to power 6. So the second term has x raised to power 6. Which is the term that we are looking for? We're looking for x raised to power 0. We see the pattern. We have to subtract 3 for the next term. It's x raised to power 9, then x raised to power 6. The next one is supposed to be x raised to power 3. And the next one after that is going to be x raised to power 0. And this is the one that we are interested in. Okay. Now this is 9c1. The next is going to be 9c2. And the next one is going to be 9c3. That's the one that we need, 9c3. Okay. Then we have x. What is going to be the power on x? This was 9, 8. The next is going to be 7. So this is going to be 6. What about the power on minus 1 over x squared? Minus 1 over x squared. This had power 1 here. The next power would be 2. The next would be 3. So we put 3 here. This is what we were looking for. Just simplify this. That will give you the result. 9c3. You do that on your calculator. Can somebody tell me what that number is? 9c3?
84.
84. So we have 84 into x raised to power 6 into, now remember there's a negative sign here, and you have cube there. Odd powers do not do anything to the negative sign, that remains there. So inside you have minus 1 over x raised to power 6. Now x raised to power 6 and x raised to power 6 get cancelled. What are we left with? Minus 84. And that's what we were looking for. This is the term that is independent of x, negative 84. Is that all right? Make sense to everyone? Right? Okay. Okay, that was question number 15. Let's look at the next one as well. 12. Let's do that quickly. Question number 12 from the worksheet. Let's try this now. I'm sorry, I'm having a problem with the other device. I'll get this sorted by next week as well. I'll try to connect LAN to it. I don't have a LAN connection with the other device right now. Wi-Fi signals are a bit weak here, unfortunately. That's why the other one keeps disconnecting. Okay. Let's do question number 12 now. All right. So this is question number 12. It says, find the first three terms in descending powers of x in the expansion of x minus 2 over x whole raised to the power 6. Okay. So that's just a simple application of the formula, the first three marks. Just have to expand this. Let's do that. That's going to be x minus 2 over x whole raised to the power 6. Just input values in the formula. In place of a, you've got x. In place of b, you have minus 2 over x, right? And in place of n, you have 6. Just input values. X raised to power n, a raised to power n, so that's x raised to power 6, plus 6c1 into the power of x is going to reduce now, that's x raised to power 5, into b, which is minus 2 over x. Then we're looking at this term, that's nc2, that's 6c2, into x raised to power 4 into minus 2 over x whole raised to power 2. How many terms did we need to expand? The first three terms. We have the first three terms. This is the first one. This is the second one. This is the third one. We don't have to go any further than this. We stop at this point, and now we simplify this. It gives us x raised to the power 6 plus 6c1. 6c1 is just 6 into x raised to the power 5 into minus 2 over x. Okay, plus 6c2. You do that on your calculator. That turns out to be 15. 15 into x raised to the power 4. You have a negative sign and you have a whole square, so it becomes positive. 2 squared is 4, and you have x squared in the denominator. And now you simplify this. What does that give you? X raised to the power 6 minus 12, x raised to the power 5 minus x raised to the power 1. In fact, x raised to the power 5 minus 1, that gives you x raised to the power 4. And then you have 15 into 4, that is 60, 60x squared. That's the expansion of the first three terms. You don't have to go any further than this because that's all that they wanted. All right, that's the first part. Let's look at the second one. What does the second one say now? Find the coefficient of x raised to the power 4 in the expansion of this thing now. Okay, find the coefficient of x raised to the power 4 in this expansion. What do we have now? We have 1 plus x squared multiplied by x minus 2 over x whole raised to the power 6. Now remember what we used to do in problems like these. We said we would start from we would start thinking from the expression that does not have a power on it. So 1 plus x squared does not have any power. So the power is 1 basically. We start from that. What are we looking for? We're looking for x raised to power 4. We start thinking from this. We want x raised to power 4 at the end. That's the only term that we're interested in. What would we need to multiply 1 by to get x raised to power 4? What power of x would we need to multiply 1 by? We would need to multiply it by x raised to power 4. What power of x would we need to multiply x square by to get x raised to power 4? x square into x square. That's going to give us x raised to power 4. So that's the other term that we need. So from this expansion, we are only looking for these two terms, x raised to power 4 and x raised to power 2. These are the only two terms that we're interested in. Now, do we have those terms here? Well, yes, we have x raised to power 4 term and we have x squared term. If we did not have those terms, we would have to find those terms as well. Okay, sometimes that happens that they ask you to expand something in the first part, and then in the second part, you need a term that you do not already have in the first part, and you have to expand it more than. All right, so that can sometimes happen. So that's why it's important to first figure out which powers of x you need from this expansion. So these are the two powers that we need, x raised to power 4 and x squared. Okay, so now all you need to do is just pick those two powers from that expansion. So what are those two powers? We just ignore everything else. Minus 12x raised to power 4 and then 60x squared. This is all that we need. Multiply 1 with this and multiply x squared with this. You could multiply the rest of it as well, but we don't need that, right? We want x raised to power 4 as the final result. So all we need to do is multiply 1 with minus 12x raised to power 4 and multiply x squared with 60x squared. Let's simplify this. This gives us minus 12x raised to power 4 plus 60x raised to power 4, and we get 48x raised to power 4. What were we looking for? We were looking for the coefficient of x raised to power 4 in this expansion. What do we say? The coefficient that we were looking for is 48. That's the coefficient. If they had asked us for the term in x raised to power 4, this is the term in x raised to power 4. But if they ask us for the coefficient is just 48. Okay, that's our final result. Make sense? So now hopefully you should be able to do the rest of the questions like this. Oh, okay. So in questions, they would sometimes say ascending, sometimes say descending. You don't have to worry about that. You will just expand it like you normally do, and you would automatically get that order. Okay, so sometimes they'll say ascending, sometimes they'll say descending. Whatever they have said, you would automatically get that from your expansion. Okay, so in this case, you get descending powers automatically like this. But even though it has not, so that's a good question actually. Even though it has not happened in the past, you won't find this in the past papers. But what if they did ask this? Because the recent papers are pretty unusual, to be honest. If you look at the last 2 years, they have tried changing the standard pattern of questions. So that can happen as well. That in this question, what if they said ascending powers instead? Okay, what if they said ascending powers? What would you do in that case? If you expand it like you normally do, this is what you end up getting, right? You get descending powers. If you wanted to reverse the order you're getting, what you would do in that case would be you would change the order of this expression. So right now it's x minus 2 over x whole raised to power 6. What you would do is you would write it as minus 2 over x plus x whole raised to power 6. Okay, and treat this as a now, treat this as b, and then expand it. Now it would be in ascending powers. Okay, so normally it does not happen in the past papers. It has not happened until now. You would just get the correct order by just applying the formula directly. But if it happens that you're getting the wrong order when you apply the formula, all you have to do is interchange a and b, and you would get the opposite order then. All right, is that okay? The rest of the process remains the same. ठीक हो गया? Let's move on. So there was another question that I think Ima asked about. Let me just look at the chat again. 24. Okay. Question number 24 from the worksheet. Let's try this as well. Question number 24. Okay. Haven't we done this before? 24. We have actually done this before, Ima. It's there in the notes. It's also there in the recordings. We did this on Monday. So it was probably the first question that we did on Monday. Let me have a look. 24 to 2106, 2121. Yeah. Okay. So on Monday, 8th January, we did this towards the end of the class. The second last question was this. So if you look at the recording, you would find this around this time. So 9:05 p.m. around this time in the recording. So you can look at the time here on top of my screen.
Okay.
Top left, right? So you'll find it at that point. It's in the notes as well. All right. Any other questions apart from this?
Sir,
Any other
there
question?
was a
Yes.
part B of this question as well.
There was a part B of this question. 24. Okay.
Yeah,
Sorry. Why?
not in the worksheet, but in other worksheets like I found in the past papers.
Okay. Can you tell me which paper it is? Because I don't have the
Wait a minute.
paper written here. Yeah. Were you able to find that?
Sir, just 1 minute.
Any other questions in the meantime? Is that the only one? Anyone else? Are there any other questions? How many of you are done with the whole worksheet now? Can I have raise of hands? All the assigned questions, of course. Okay, that's good. Aisha, Rijal, Hazim. Aisha and Rijal, what about you?
Sir, I have a few questions left. I'll finish it by tonight.
Okay, all right. Please make sure that you're submitting the worksheet as well. Otherwise, if you don't submit, you will keep delaying it. So try to do this, that you submit the worksheet by the end of the week in which we complete a topic. All right. So do this. Give yourself deadlines. I'll also put deadlines there. So try to follow the deadlines. Otherwise, you will not be able to complete all of this practice until the end of the course, and then it would not be as beneficial. So do the work alongside, do the practice alongside. That's really, really important. Okay. And submitting it would also help you do it on time. So that's where I know that I can see who has submitted and who has not submitted. So you need to give somebody else you need to basically give others somebody else some control over what you're doing, so that you keep a check on yourself as well. Otherwise you will just keep procrastinating, and that's not going to help. Ima, were you able to find that paper?
No, sir.
Okay, chale. What we'll do is we will discuss it in another class then. So try to find it. What you can do is you can post it in the WhatsApp group as well, and I can explain it there. Okay.
Okay.
Or can you at least tell me what the second part is, so I can maybe figure out at least if it's the same topic or another topic? What does the second part say?
It was like an expanded version, and you have to make like, I think, substitution or something.
Okay. So you have a similar question. I'm not sure if you've done a similar question here or not. Yeah, probably we haven't. Let's actually do a question like that, because that's an important one. Nobody has asked about it. You will find a couple of questions in this worksheet like that as well, where you have to do substitution. So for instance, if you look at question number 6, you should definitely try this if you haven't. This involves that substitution. It explicitly says that you have to use that substitution, but sometimes they don't give you that substitution. Let me find that as well. You can attempt that one. Yeah, let's do this. Question number 20. Let's do this and then we start quadratics. At least we can do some introduction of quadratics today after this question. Question number 20. So the other one that I showed you earlier, that's very similar as well. The other one was question number 6. Okay, you can try 6 after this yourself. I'm going to do question number 20 because we haven't done one like this. Yeah. Okay, let's do this. Question number 20 from the worksheet. Okay, so it says find the first three terms. Find the first three terms in the expansion of 2 minus y whole raised to the power of 5. Let's do this first. 2 minus y whole raised to the power of 5. How do we expand this? It's pretty straightforward. We just have to apply the formula. 2 minus y whole raised to the power of 5. The first term is a, the second term is b, and n is 5. Let's just input values in the formula. 2 raised to the power 5 plus 5c1 into 2 raised to the power 4 into minus y plus 5c2 into 2 raised to the power 3 into minus y whole squared. And that's it. You have three terms now. We can simplify this. That gives us 32 plus 5 into 16 into minus y plus 5c2, which is 10, into 8 into y squared, right? Minus y is inside the bracket, whole squared. It makes it positive. And now you can simplify this to get 32 minus 80y plus 80y squared. That's the expansion. So we found the first three terms of this expansion. Now, what does the second part say? The second part says, use the result in part 1 to find the coefficient of x squared in the expansion of this thing. Okay, so it says 2 minus 2x minus x squared whole raised to power 5. Now we have to expand this and find the coefficient of x squared. That's what we have to figure out. And we have to use the result in part 1 somehow. Now, how is the first part relevant for the second part? How is the first part relevant? If you notice, The two expansions, the two expressions that you have here, this one and this one, they're very similar. How are they similar? The power in both of them is 5, right? Both have power 5. The first term in both of them is 2. You have 2 there as well. Then you have a negative sign outside. In place of y, the second expression, we have 2x minus x squared. So in place of y, we have got this thing. Now, even though this expansion originally is a 3-term expansion that the binomial formula does not work on. Remember, for binomial expansion, we need 2 terms, a and b. Here we have 3 terms. But what we do instead is, we say, let's treat 2 as the first term and this as the second term. And now we compare it with what we did in the first part. In the first part, what we have done is, we have expanded 2 minus y whole raised to power 5, and that gave us 32 minus 80y plus 80y squared. That's what we've done in the first part. If you compare with what you have in the second part now, the only thing that has changed is that in place of y, we have 2 minus, I can actually write it like this first. So it's not much clutter. Yeah, so in place of y, we've got this thing. That's the only difference. Y has been replaced with 2x minus x squared. Now we've already done this expansion for y. All we have to do is, on the right side as well, just put 2x minus x squared in place of y. All right, because if it was y, the expansion would look like this. If it is something else, on the right side as well, y would be replaced by that thing. So it becomes 2x minus 80 into 2x minus x squared plus 80 into 2x minus x squared whole squared. So you just replace y with 2x minus x squared. And now, what are we looking for? We're looking for the coefficient of x squared. We can just simplify this and find the coefficient of x squared from this. Let's simplify. We get 32 minus 80 into 2x. That gives us 160x plus 80x squared plus 80. Now expand this. This is a minus b whole squared. You can do this directly, right? A minus b whole squared. That is a squared minus 2ab plus b squared, right? Just apply that here. 2x whole squared. That gives you 4x squared minus 2 into 2x into x squared. That gives us 4x cubed plus square of x squared, which is x raised to power 4. Now, again, what are we looking for? We are only interested in x squared terms, so we can ignore everything else. We can just focus on the x squared terms, the ones that we need. That's this and this. Let's simplify this and see what we get. We have, just ignore everything else, 80x squared plus 80 into 4, that is 320x squared. We're not bothering with simplifying the rest of it. And that gives us 400x squared. We were looking for the coefficient of x squared. What's the coefficient of x squared that we were looking for? It's 400. So sometimes this happens as well, that in one part, they ask you to do an expansion. And then in the next part, they want you to use that expansion to expand something else. So you have to compare the two and see what has changed. The power was the same. The first term was the same. The only thing that changed was the second term. In place of y, we've got 2x minus x squared. So in our expansion in the first part as well, we just replace y with 2x minus x squared to get this result. Okay. Now, if you look at question number 6 here, if you look at question number 6 here, you've got the same thing here as well. I'm sorry, this is not working. Okay. If you look at question number 6, you have to expand this thing in the first part and then use this substitution, u equals x squared plus x squared. They have told you explicitly here which substitution to use, because if you compare the two, 2 plus u whole raised to power 5, that's something that you would have expanded in the first part already. In the second part, it says 2 plus x squared whole raised to power 5. You have to expand this thing. So what has changed? What has changed is this thing. In place of u, we have x plus x squared. And that's the substitution they're asking you to use, that just replace u with x plus x squared. Okay, so sometimes they give you the substitution. At other times, you have to figure it out yourself, like we did here, by comparing the two expressions. Is that all right? Any problem with this? Any problems, anyone?
No.
Okay, let's have a 1-minute break and then we start with quadratics. Okay.
Sir, I've sent the question in the group.
Okay, let me have a look at that as well, in case it is different. Okay, so it's not a second part of that question. It's a different question. Let's do this quickly. Let me see how I can share it here. Yeah. Okay, so it's not working for some reason. Okay, let me just write the question down. It'll take just more time. Okay, so the question is, it's from May, June 21, paper 1 2. I think that's going to be quicker, yeah. Just copy it from here. June 21. Okay, I'm sorry. Can't find it right now for some reason. Okay, fine. Okay, so this is the question that you're talking about. Let's quickly do this. Which I'm sorry, I think we are running out of time for quadratics now. देखेंगे फिर हम end पे if we're able to do maybe just a couple of basic concepts. Okay, let's understand this one. It looks like a good one. तो हम एक दफा discuss कर लेते हैं जल्दी से. फिर हम देखते हैं if we have time to start quadratics. The coefficient of x in the expansion of 4x plus 10 over x whole cube is p. The coefficient of 1 over x in the expansion of this is q. Given that p equals 6q, find the possible values of k. All right, let's try this. Let me copy the formula. This is the formula that we have. Okay. So we are given that the coefficient of x is p and the coefficient of 1 over x in this other expansion is q. Now, what does 1 over x mean? 1 over x is basically the same thing as x raised to a power minus 1. So keep that in mind when you're looking at the pattern. 1 over x would be x raised to a power minus 1. Okay. Now, what do we do? Let's start with the first one. 4x plus 10 over x whole cube. 4x plus 10 over x whole cube. Let's expand this first. What are we looking for in this expansion? We're looking for the coefficient of x. Let's expand the first two terms and try to find the pattern that emerges. 4x whole raised to power 3 plus EC1 into 4x whole raised to power 2 into 10 over x. What's the first term? In fact, it's only power 3. So if we wanted, we could just expand the whole of it. But let's actually look at the pattern. We might have it already because the first term is x cubed. What about the second one? X squared divided by x. That's x. And actually, that's the one that we're looking for, right? We were looking for the coefficient of x in the first expansion. This is the term that is going to give us that coefficient. All right, that's the one that we're looking for. So now we just ignore everything else and just simplify this expression. Okay, this is the one that we need for the first expansion. Let's simplify this. 3c1 is just 3. 4x whole squared, that gives us 16x squared, multiplied by 10 over x. X and x get cancelled. You have 1x left in the numerators. 3 into 16 is 48. 48 into 10, that's 480x. It says the coefficient of x in this expansion is what? This coefficient is p. All right, this coefficient is p. So what we get from this is that the value of p therefore should be equal to 480. Does that make sense to everyone up to this point?
Yes.
Right? Okay. Let's start working. P equals 1, 480. Now, let's look at from the second expansion, you need x raised to power minus 1. And they are saying that this is supposed to be q. Let's do the second expansion now. That is 2x plus k over x squared whole raised to a power 5. This is the second expansion. What are we looking for from this expansion now? We're looking for the coefficient of 1 over x. What does 1 over x mean? 1 over x means x raised to power minus 1. Okay, 1 over x means x raised to power minus 1. Now, that's what we're looking for. What's the first term? The first term is 2x whole raised to power 5 plus 5c1 into 2x whole raised to power 4 into k over x squared. Now we stop at this point, look at the pattern that we have from this. The first term is x raised to power 5, right? And then the next one is x raised to power 4 in the numerator, x squared in the denominator. What does that become? X squared, right? X raised to power 4 divided by x squared, that gives you x squared. So what's the pattern? The difference is -3. Okay, difference in powers is -3. So the first one is x raised to power 5, then you have x squared. The next one, therefore, is going to be x raised to power -1, and that is the one that we're looking for, right? So let's just expand one more term, and that gives you 5c2 into 2x whole raised to power 3 into k over x squared whole raised to power 2. Okay, now let's simplify this one and see what this gives us. 5c2 is 10, 2x cube is 8x cube into k squared divided by x raised to power 4. Let's simplify this. 10 into 8 is 80. X cube over x raised to power 4, we're going to have x in the denominator, but remember what were we looking for? We were looking for the coefficient of 1 over x. So we'll keep that separate. 80 is multiplied by k squared, and then we have 1 over x, or we could say this is x raised to power -1. That's what we're getting. So what's the coefficient? The coefficient is 80k squared. What was the coefficient supposed to be? The coefficient was supposed to be q. The coefficient of 1 over x, that was q. So what do we get from this? We get q equal to 80k squared. That's the value of q that we have from this. Okay. So now we have p. P was 480. That's a number. That's one thing that we were looking for. No, we were actually looking for k at the end. Okay. So p equals 480. Q equals this. Now we're also given in the question that p equals 6 times q. Now, since we are looking for the values of k, we will need to use that third equation that's given there as well, which says p equals 6 times q. All right. And we need to find the value of k somehow. Now, we already know the value of p. We found that earlier. P was 480. We can input that here. 480 equals 6 times q. Q equals 480 over 6. What's that? 80? Yeah, it should be 80. Q turns out to be 80. We put that here. 80 equals 80k squared. And you get 1 equals k squared. What's the value of k that we get? What's the value of k?
Plus minus square root of 1.
Plus minus 1, right? So do not forget the plus minus. You have two values, plus minus 1. And the question statement actually hints towards this as well, that you are going to have multiple values of k, because the question says, find the possible values of k. That means you can't have one answer. You are going to have multiple answers. So that should tell you that you are going to use both these values here. K equals either +1 or -1. And that's going to be the solution. Is that all right?
Sir, in the answer, if I write square root 1, is that fine? Plus minus square root 1.
No. You have to simplify that. You have to write +-1, because square root of 1 is 1. You can simplify this. If it was, for instance, plus minus square root of 3, then you could leave it like this. But you can't leave, for example, plus minus square root of 4, because this is something that you can simplify to +-2. So you have to do this, but square root of 3 could be left like that. Square root of 1 can't be left like that. You have to write 1 there, not square root of 1. Okay. All right, so I think we are going to start quadratics in our next session then, because we only have like 10 minutes left. It's not going to help. But that's okay. We're done with this topic. We've done enough practice in this as well. And that's what I would want, that you do a lot of practice. You do the assigned questions. If you have any problems from that, you ask me about that. And then just like Ima did, was this Ima or Ira? Yeah, so one of those. You have to attempt more questions apart from the worksheet as well. So I would recommend, I think I've said this before as well, you do the assigned questions from the worksheet for every topic. Okay, that will make sure that you're done with all the concepts that you need for that topic once you're done with the assigned questions. And once you're done with all of them, you move on to recent papers questions. So by the end of this crash course, alongside, what you have to try is that you're done with all the past papers from 2020 onward. Okay, leave 2023 for now. You should do that at the very end before your exams. But 2020 to 2022, these 3 years, you should be doing these papers alongside. Okay, just 3 years. These are very important because sometimes in recent papers, they ask things slightly differently. So you need to get familiar with those things as well. And then if you have any problems in any of those questions, you can ask about them in class as well. All right. So this has to go hand in hand. You have to do a lot of practice. That's how you will get the most benefit out of this course. All right. So that's it. I think we will end with this. We will be starting quadratics in our next session then. If you have any problems, you can let me know. So I'm here for let's say 5-10 minutes in case anyone has any other questions from any topic. You can ask me about them. Otherwise, for the class, that's it for today. Okay, if you have
So
any individual
another
questions,
question as well.
yeah, sure.
I'll send it to you.
Yeah, so if others want to stay, you are welcome to stay. If you have any other questions, you can ask me about them as well. But this covers our topic. So if you are free, if you want to leave, if you want to go somewhere and do something important, although this is also important, but if you want to do something else, you can do that. Otherwise, you can stay here as well. Maybe Ima has another interesting question that might help you as well. Abdullah, no. So you have done enough practice in binomial. If you want, you could do more questions from recent past papers, pick up a paper. So I would recommend, if you can, get any topical book, read and write, MS books, red spot, but unsolved. Do not pick up solved topicals, please. They're not helpful. They will just make you look at the solution again and again. You should not be doing that. So take unsolved topicals that do not have the answers there. They just have the marking schemes at the very end. Do recent papers questions from that. So topicals from 2020 to 2022, focus on that alongside the worksheet questions. So do that as much as you can. Okay, and then of course, if you have any problems in any of those questions, you can always come back to class and ask about that. All right, so let's have a look at this question that I must asked about.
Sir,
It's yes.
Assalamualaikum, sir.
Walaikum assalam.
Sir, wanted to ask, is giving maths composite doable?
Are you in A1 or A2?
Sir, I'm in A2. I'm actually giving composite.
Yeah, composite is doable, as in a lot of people do it. Depends on how well prepared you are. So in Lahore, for instance, LGS, ISL, these schools have a policy that all their students give composite. So yes, a lot of people do it. It really depends on how well you have studied and how strong your concepts are.
Sir, for P3, I have watched your videos apart from college.
Yeah, just watching does not do anything. You have to, of course, do a lot of practice. So if you've done that, done enough practice, done all the topical questions related to those concepts, then yes, that should be good enough. But P3 requires a lot of practice. So just make sure that you've done that.
Sir, the thing is that whenever I do some topic, I forget the previous thing.
So you have to keep practicing ना, that's important. आपको साथ साथ पुराने papers भी करने हैं. So जो भी आप topic कर रहे हो, you do topical questions from that, and alongside pick up one topic पहले वाला जो आप साथ साथ उसके साथ revise कर रहे हो. Otherwise that's what happens. Yes, you start forgetting stuff. तो आपने साथ साथ revision भी करनी है. I'm sorry, I'm just trying to look for this
Thank you, sir.
paper somewhere. Paper 1, 2. Yeah, okay, finally. Question number 8. Yeah, this is the one. I'm on which part of this? I think the first part is not that difficult. Or is
B
it?
part.
B part. Okay. Okay, let's have a look at this. Part B of this. It's given that, so basically, when it says it's given instead, that means the first part is not relevant. Okay. So there was a first part of this question as well, but that's not relevant to the second part. Okay. This is independent, the second part. So let's have a look at this. So it says it's given that in the expansion of 4 plus 2x into 2 minus ax whole raised to the power 5, the coefficient of x square is k. It is also given that there's only one value of a which leads to this value of k. Find the values of k and a. Okay. Now let's expand it. So you have 4 plus 2x whole, into 2 minus ax whole raised to the power 5. We have this binomial formula. We're going to keep this in front. Okay, the first thing is we're given that the coefficient of x square is k. So we are looking for the coefficient of x square, okay, in this expansion. How do we find that? What do we multiply 4 by to get x square? You multiply it by x square. What do you multiply 2x by to get x square? You multiply it by x. So these are the two terms that you are specifically looking for in this expansion, okay? Now, I think you've probably done that in the first part, this expansion. Yeah, so you would have done this expansion in the first part already, so you could use that. But since we haven't done the first part, we will do that now. 2 minus ax whole raised to the power 5. Let's expand this thing. 2 raised to the power 5 plus 5c1 into 2 raised to the power 4 into b, which is b. What's b now? Minus ax multiplied by minus ax. The first term is just a constant. The second term has a coefficient, has x. The first is x raised to the power 0. So you get the pattern. The powers are just increasing 0, 1, 2, 3, 4, 5. So the next one is going to be x squared. That's what you need. X and x squared. Let's expand one more term. 5c1 into 2 raised to the power 3 into minus ax whole raised to the power 2. And just ignore the rest of it for now because it doesn't look like we need that. What do we get from this? 32 plus 5 into 2 raised to the power 4. 5 into 16, that's going to be 80. Then you have to multiply that by minus ax. That's going to become minus 80 times ax. Okay, you'll simplify this, you'll get minus 80x. Plus, okay, this was 5c2, sorry. 5c2 is 10. So you have 10 into 8. That's also 80. But then minus is inside the square now. So that gets eliminated. You have a squared x squared. This is what we get. All right. Now it says that the coefficient of x square is supposed to be k. The coefficient of x square is supposed to be k. Now, what's the coefficient of x square? This is the coefficient of x square. 80a squared. So 80a squared should equal k. All right, so k equals 80a squared now. And now the question says, it's also given that there is only one value of a which leads to this value of k. So there should be only one value of a that gives us this value of k. Okay, that's interesting. Let's look at the first part again. Okay, fair. That got lost. Achha. What was the first part? Could you repeat that? First part में उसने क्या कहा? Aima? It was this expansion, and then they asked about the possible values of a given what?
I think the coefficient of the possible values of a, they were 3/8 and 1/8.
Okay, so in the first part, I'm just thinking if that might need to be used here anyway. Coefficient of x squared was given to be minus 15. I just found that. And what were the possible values of k?
The possible values of a,
Yeah, that you got in the first
3
part.
over 8, 3/8 and 1/8.
3/8 and 1/8. Okay, so these are the values of a that we got in the first part. Okay, so that was the first part. The coefficient of x squared was given to be minus 15 there. But now we are not given that the coefficient of x squared is minus 15. Okay, so that's k instead. And it's also given that there's only one value of a that we should be getting. Okay, so the value of a here should only be 1. In the first part, we got 2 results. And the reason for that would be we have 80a squared. We put that equal to that. And we got plus minus that. Minus 80. Okay. Values of k and a. This is what we are given. The next terms we would have okay, all right. So we're not done with this. This is not yeah, so we're doing some error here. So basically, we were given that the coefficient of x squared in this whole thing was k, right? We did this a bit too early. We have just found this expansion at this point, right? They are talking about the coefficient of x squared in this expansion. So we haven't done that yet. So this is not k yet. This is this expansion for now, right? Now we need to use this thing. This is 4 plus 2x. 4 plus 2x multiplied by 2 minus ax whole raised to the power 5. What does that turn out to be? 4 plus 2x. Remember what we needed? We needed the x squared term and the x term. Just focus on that. The x term is minus 80ax and the x squared term is 80a squared x squared. Now we multiply this. We only multiply the terms that we need to multiply. 4 into this and 2x into this. And see what we get from that. 4 into 80 squared x squared. What does that turn out to be? 320a squared x squared. And 2 into minus 80a, which is minus 160a x squared. So now if you were to look for the coefficient of x squared in this, what's that? That's 320a squared minus 160a whole multiplied by x squared. What's the coefficient of x squared? The coefficient of x squared now is this thing. And this is given to be k. All right. Is this clear until this point? This coefficient of x squared is supposed to be equal to k. And now what we can do is we can just put them equal to each other. We get 320a squared minus 160a. That should equal k. That's an equation that we get. So we found the coefficient of x squared in that expansion. How do we do that? We knew that we just needed the x squared term and x term from this expansion. We found the x squared and x terms. We multiplied them with 4 plus 2x, simplified everything. The coefficient of x squared turns out to be this thing. And now, since we know that the coefficient of x squared is supposed to be equal to k, we put that thing equal to k. And this is something that we get from that. So now we have 320a squared minus 160a, that equals k. Okay, so that's what we have. Now we need to somehow figure out the value of k. We are given that there's only one value of a which leads to this value of k. Find the values of k and a. Okay. So now what we have is a quadratic equation. This is a quadratic equation. All right. Now, here we would actually have to use a concept of quadratics, which we are doing next. But in case you've covered the syllabus once, you might remember somewhat what you've done there. Remember discriminant? If you have quadratic equations, if they have only one solution, what's true about them? B square minus 4ac, what is that equal to? That is equal to 0, right? It's greater than 0 if you have multiple solutions. You have two different solutions. If you have two equal solutions or only one solution, b square minus 4ac is equal to 0. And if you have no solutions, this is less than 0. We'll be talking about this in the next week. So here what we have is we have a quadratic equation that looks like this. Okay. And we are given that there is only one value of a that we're going to get from this. That means the solution of this equation is only one value of a. There can't be multiple values, which means there's only one solution of this equation. So b square minus 4ac therefore is supposed to be equal to 0. Now in this equation, what are we going to input in place of a? In place of a, we've got 320. In place of b, we've got minus 160. And in place of c, we've got minus k. Just input values here. B is minus 160 whole squared minus 4 into a, which is 320, into k, into c, which is minus k, that equals 0. Now we can simplify this. 160 squared, what's that? 16 squared is 256. 256, is that 2 zeros or 3 zeros? 2 zeros? Can somebody confirm this, what this value is? 25600?
Sir, 20.
Okay, so 25600, that's what you get, 25,600 minus into minus, that becomes plus 4 into 320, that's 640, and 1280 times k, that equals 0, and the value of k turns out to be minus 25600 divided by 1280. What do we get from this?
Minus 20.
Minus 20. So that should be the value of k that we get from this. Once we have the value of k, it's pretty long. Once you have the value of k, now you can input this back. in this equation, solve that quadratic equation, we'll get the value of a from that as well. So how do you do that? We can use this equation here. 320a squared minus 160a minus k, that becomes minus into minus 20 equals 0. Now it's a quadratic equation that you can solve. 320a squared minus 160a plus 20 equals 0. Divide everything by 20 to simplify this. That is going to give you 16a squared minus 8a plus 1 equals 0. You can see if you can factorize this, you can, because you can say 16a squared minus 4a plus 1 equals 0. You get two factors from this, 4a minus 1 and 4a minus 1, which are the same factors. The value of a turns out to be 1 over 4. And that's the value of a that we get. That was a pretty tricky question, but a good one. You needed concepts of quadratics for this. All right. I hope that did not scare anyone a bit too much. That was a 4-mark question. So just an exam tip, if you get stuck at a question like this during an exam, it's okay. You don't have to spend 20 minutes on that, okay? You skip that question for that point in time, complete the rest of the paper, come back to it again. Because otherwise, if you get stuck at a question like this in the middle of the exam, what happens is you can end up skipping an easier question at the end of the paper because you would not have enough time left for that. So never get stuck in the middle of the exam on something like this. Once you've tried something, if it's not working out for you, it's all right. If it's a difficult question, a lot of other people would be finding it difficult as well. The threshold will take care of it. So don't panic too much at that point. Skip that part. Don't skip the whole question. There are always questions in which one part is difficult and the other parts are not so difficult. So you should do what you can. But if you get stuck at any part, leave that particular part for that point in time. You can always come back to it later. If you get stuck in the middle of the exam and spend like 15 minutes on one part, even if you're able to figure it out, you will end up having less time for maybe some easier questions for in the rest of the paper, and that might cost you more. So that's very important. This happens in every single exam, that people end up panicking because they get stuck at a question and they lose a lot of time and they end up missing easy marks towards the end of the paper on some simple question. So that's important. All right. Any questions? Anyone? Any other questions? Is that it?
No.
Okay. So I'll see you again on Monday, inshallah. We will be starting quadratics. That's it for today. Allah Hafiz.